Hey there everyone, welcome back to Leetcoding. I'm your host Faraz. So recently I uploaded a lecture on recursion and backtracking. So it was an introductory lecture. In that lecture I had 3 questions. So 2 are the basic questions and 1 was a bit advanced. So if you didn't get everything into that lecture, I'm going to repeat the problem number 2 of that lecture, that is permutations, again, in order to make you understand this, so that you can solve all the questions which will be coming up in the future lectures. And if you didn't understand everything, you don't have to worry, because we are going to solve a lot of questions on recursion and backtracking very soon. So let me just start with this problem and let me just try to make you understand how does recursion work in this problem. Also, if you understand this problem in that video very clearly, you can just skip this video. It is of no use for you. So let me just start with this. We have to find the permutations of certain numbers. So if we try to find out the permutations of 1, 2 and 3. Okay, before that we already know if we have only one number, the permutation will be that number itself. If we have two numbers, let us say 1 and 2, then the permutation will be 1 2 and 2 1. Okay, so basically what we do when we try to find our permutation, so we keep one number to ourselves. Okay, each number one by one we will keep it to ourselves. So we kept 1 to ourselves, and then we try to find out all the permutations of 2 3. Okay, and then place them, append them at the back of 1. So the permutations of 2 3 will be 2 3 and 3 2, right? So I will just append it at the back of 1. So 2 3 will be added here, then 1 3 2 will be added here. So I was able to find out 2 permutations when I placed 1 at the first position, first location, right? Okay, now similarly I will place the second number at the I will keep the second number to myself, that is 2. So I will keep 2 to myself, and I will pass 1 and 3, and I will generate all the permutations of 1 and 3 and append it at the back of 2. So the permutation of 1 and 3 is going to be 1 3 and 3 2, sorry, 1 3 and 3 1. So I will append it here, 1 3 3 1. I got 2 more permutations when I placed 2 at the beginning. So I kept 2 to myself, right? Now in the third case I'm going to keep 3 to myself, and I will generate all the permutations of 1 2, and I will append it at the back of 3. So 3 here, 1 2, 3 here, 2 1. Okay, very clear. Now let us move on to a bigger example and see how does these things work. So let us say if I have 4 numbers, 1 2 3 4. Okay, now again doing the same strategy, again following the same strategy, I will keep 1 to myself, and I will try to generate all the permutations of 2 3 4 so that I can append it at the back of 1. Now we already know the permutations of 3 numbers, 3 different numbers are basically 6, right? You must know this from the mathematics, or you must know this from the last example that we used. We were permuting 1 2 and 3, and we were able to find 6 permutations. So the permutations of 3 numbers, 3 different numbers, are 6. So we will be able to generate 6 permutations from 2 3 4, and I will append those 6 permutations at the back of 1. So 1 1 1 1 1 1 and 6 permutations. Let me just give you an example here. So those permutations are going to be 2 3 4, 2 4 3, 3 2 4, 3 4 2, 4 2 3, 4 3 2. Okay, so these are the 6 permutations that I will be able to get with these numbers, and I will append 1 at the front of them. Nice. Now again following the same strategy, I will keep 2 to myself, and I will try to generate all the permutations of 1 3 4, and I will again append them at the back of 2. So 2 2 2 2. Similarly, I will be able to find 6 permutations when I keep 2 to myself, or 2 at the front, right? Similarly, 3 at the front, 4 at the front. Now, did you notice here that when I was generating the permutations of these 4 numbers, I also wanted to generate the permutations of these 3 numbers and then append them in the front of 1. When I kept 2 to myself, then I wanted to generate the permutations of these 3 numbers, 1 2 4 1 3 4, and then append them at the front of 2. Okay, let's say if I have 5 numbers, 1 2 3 4 5, then I will keep one by one each of these numbers to myself. So if I keep 1 to myself, I want to generate the permutations of these 4 numbers. If I keep 2 to myself, I want to generate the permutations of these 4 numbers and append them at the front, at the back of 2, right? So if I have n distinct numbers, I also want to generate the permutations of n minus 1 numbers so that I can append them at the front of each of the numbers one by one, right? Now, so to find the permutation of n numbers, we want to find the permutations of n minus 1 numbers, and to find the permutation of n minus 1 numbers, we want to find the permutations of n minus 2 numbers. Similarly, permutations of n minus 3 numbers, till the time we have only one number left. Okay, awesome. So now this gives us a hint of using recursion here. Why recursion? Because recursion is a function calling to itself. So we can clearly see here, if we are calling the function to permute certain numbers, that function itself required to permute n minus 1 numbers. Okay, these are the same functions because they do the exact same functionality. So the function in which I am trying to permute n minus 1 numbers, which was in fact called by the function in which I wanted to permute n numbers, this will further call a function which will permute n minus 2 numbers. So again the same functionality, that's why I'm going to call, the function is going to call again itself. So without wasting further time, let me just dive into the code so that you can understand it. So now let me just try to code this. So I'm keeping a helper function, or let me just name this as permutation. In this I will pass the given vector of int. So these are my unique numbers inside this nums, and I will keep track of the index I. So for more clarity, let me just try to explain you this way. So let's say I have the collection of numbers as 1 2 3 inside nums initially. Okay, this is my nums, and I'm trying to create the permutation, right? So first of all, I said that I'll be keeping 1 to myself. So if I keep 1 to myself, I will be storing it somewhere, and I will remove it from these nums. So I'll keep it somewhere, maybe in some other vector, and I will remove it from this nums, and I will try to generate all the permutation of these two numbers 2 and 3, and I will just try to append them here, over here, in front of 1, right? So okay, let us say I read a function. That function returns me a vector. It returns me a vector of int, and it will be having the permutations of all the numbers, right? It will be actually a vector of vector because there could be many permutations. So I will have this function, and as I said, I will keep all the numbers one by one to myself. So for that I'm running a loop for int I is equal to 0, I smaller than nums dot size minus 1, nums dot size, yeah, nums dot size I plus plus, and I'll keep each of these numbers one by one to myself. So this is my answer. Okay, and here I'm creating a temporary vector of int temp. In this I will be storing I'm keeping to myself the number nums of I. This is the number that I'm keeping to myself, and rest of the numbers I will have to pass. Okay, so rest of the numbers should be passed into this function again. So I'm keeping this number to myself, and rest of the numbers, like for int j is equal to 0, j is smaller than nums dot size, and j plus plus. So now I will go to I will pass each of these numbers, just except the number at the place I, because I'm keeping it to myself. So if I is not equal to j, I have to pass all these numbers to the permutation, right? So for that I'm keeping here a vector, again a vector of int, maybe nums2. So in this I will have to insert all the numbers except the ith number. So nums2 dot pushback nums of I. Okay, so this is what I'm going to pass here. I just removed the reference sign here because I'm going to change it. So nums dot pushback nums of I. I'm inserting all the numbers, just accept the ith number. After this, I will pass this number to the permutation. So I kept the ith number to myself. That number is stored in temp. Okay. Now I created another vector, that is nums2, and inserted all the numbers except the ith number into this number. Finally, I will call the function perm. So for that, I will keep a vector of vector int. This will be v, which will be equal to permutation of the nums2. Okay, I will have the permutation of nums2. Basically, then I will have to append all these permutations at the back of 1. So for that, what I can do is, for whatever permutations that I have got, so for auto a belong to v, so this is the a is the permutation. I will be going to each of these permutations, and what I will do is to append 1 at the front of all these permutations and insert it to the answer. Instead of appending it at the front, I can also append it at the back. It won't change the results, so I can just do this. So a dot pushback the ith number. So the ith number is nums of I, right? So I can push back this, and I can simply insert this into the answer. So answer dot pushback a, and I don't need this. I don't need this part. Okay. Finally, I can return it from here. Return answer, and let me just try to run this once. Although this is not the optimal approach, I will tell you why. I will make this code much more simplified, but this is this for basic understanding. So this for basic understanding that we have discussed. What we have discussed, we are picking each of the numbers one by one. Okay, except that number, all the numbers will be permuted. Hence we are calling this recursive function perm here. Except in nums2 there are all the numbers except the ith number, so I'm calling perm on this. I have all the permutations of all the numbers except the ith number. Now once I have all those permutations, so at the back of those permutations I am appending I. Okay, I could have appended at the front also, but appending at the back is much more simple, so I'm doing that. And finally I'm pushing that back into the answer, returning the answer. And let me just try to run this once and hope it gives us the correct answer and not the compilation errors. There are compilation errors. Okay, so this function is perm. So basically we forgot to add a base case here. The base case is when there are no element left. So nums.size, when it got reduced to 0, in that case there are no elements, so we can simply return an empty vector here. Okay, so I can just run this now, and there's also one more problem here. So we have to take all the elements except the ith element, so we have to use nums of j. Let me just try to run this again, and it got accepted because it is giving us correct answer. But let me just try to submit this. Most probably it should give us TLE because we are using a lot of space, it is not giving us TLE. But there's another optimized approach. So here we are using a lot of extra space. We are making the copy of these vectors again and again. We are using so much of the recursive stack in which we are creating these vectors again, and this is a lot of computation. So we need to simplify this. First of all, you should understand this thing. Okay, if you understood this thing, now let's move on to a more optimal solution. Okay, that is going to use a very less space, and that will be much simplified in terms of coding. So basically what I'm doing here, I am trying to keep one number to myself and permute rest of the numbers, and the number which I'm keeping to myself, I will take all the numbers one by one, right? So if I have 1 2 3, I will take 1 to myself and permute 2 3, then I will keep 2 to myself, permute 1 3, then I will keep 3 to myself and permute 1 2. So instead of doing like that, what I can do is 1 2 3. So what I can do is I can keep the first number fixed at the first place and then call the permutation on the rest of the numbers. Then we want to fix the second number, so we'll fix 2 here and then try to find out the permutation of these. Then I will fix 3 at the first position and try to find out the permutation of all these 2 and 1 here. Okay, so how can I achieve this? So if you want to achieve that, what I can do is I will at this position I will try to keep each of the numbers one by one. So first of all I will keep 1 here. Okay, next time I want to keep 2 here, so I will swap these two numbers. So 2 will come here and 1 will go here. Then I want to keep 3 here, so I will be swapping 3 with 1. So 3 will come here and 1 will come here. So let me just show you the help of the code what I want to say here. So let us say I want to find the permutation starting from the 0th element, right? So I will pass here int I. This will be 0 initially because I want to find the permutation starting from the 0 till the end. So I will run a loop for int j is equal to I, j is smaller than nums dot size, and j plus plus. Okay, then I will swap this nums of j with nums of I. Basically at the ith position I'm trying to place all these elements starting from I till the end. I'm trying to place all these elements one by one. Okay, and then I will find the permutation of rest of the numbers. So okay, so nums and I, nums comma I plus 1. Alright, and after coming back I'm going to undo the changes that I made. So swap of nums of I again with nums of j, it is going to undo the changes which I made. Simple. Okay, so at the end when I is equal to nums dot size, when I reached till the end, in that case I have the permutation stored in this nums. This nums will have one of the permutations, so I can simply store this into the global answer or the answer that I have to return. So answer dot push back this particular permutation, that is nums. Okay, and I can return from here. Also I can create the global answer. So you don't have to create it globally, you can either pass it using reference in this function perm, or you can also create it globally, but the better practice is to pass this in this perm as a reference. So after doing this I will be calling to this function, and I will, okay, we don't have to return it because now the type is void, and then you can return the answer. And here let me just write void. Let me try to run this. If I is nums dot size, okay, swap. Now you can notice one thing in this code. We are, first of all, we are not returning anything, so we are not creating any extra space here. Second, we are passing it as a reference. So in the previous example we could not pass it as a reference because we were changing it. Now we are not changing it, so we can pass it as a reference. So again this space is saved, because if you pass it without using a reference it will create a copy in the memory. So let us say if you have let us say 50 recursive calls, 50 times the function is calling to itself, each of these 50 times is num will create some space into the memory. Okay, it will take this memory. If you pass it as a reference, then only one copy will be made and rest of the copies won't be made. So you should always try to pass anything, a vector or a string, as reference into this recursive calls. Okay, now there's another error. What is the too few arguments? Where? Okay, so here there are too few arguments in this case because we have to pass 0 from here as well. Alright, so it got accepted, and you can see the memory usage is also less this time, and it is much faster. I hope. Yeah, it was 12 milliseconds and it is now 4 milliseconds. Awesome. So this is how you can do this, right? 0 milliseconds. Nice. I hope those who were not understand it in the previous video, they understand it now. So if you want to suggest anything, please leave your comments. If you like the video, hit the like button and make sure to subscribe to the channel. And make sure to hit the bell icon to get the notifications of the latest videos. Thank you.